Let us solve some questions on integration of trigonometric functions. The diagram shows the part of the curve y equal to sine square x for x between 0 to pi. We have to show that derivative of this function is sine 2x. First part is if y is sine square x, then its derivative is going to be dy by dx is equal to twice of sine x, and then we will differentiate sine x with respect to cos x. This is just plain chain rule. So 2 sine x cos x is sine 2x. Okay, very simple. First part is over. Second part says that hence find the x coordinate of the points on the curve at which the gradient of the curve is 0.5. So we have to find out the points on the curve, means the x coordinate where this derivative, because the gradient is given by the derivative, this derivative is given as 0.5. That means we have to find the x coordinate where the gradient, which is sine 2x, is half. Sine 2x is half when the angle is 30 degrees, or since it is a real number, we have to find out the x coordinate, means it should be a real number, not the in degrees. So if sine 2x is half, means 2x is pi by 6, 30 degrees. It means x is pi by 12. Okay, so where the gradient is half, that x coordinate is pi by 12. Okay, second is over. Third part says that by expressing sine square x in terms of cos 2x, we have to find the area of the region bounded by the curve and the x-axis between 0 to pi. So this is a curve. We have to find the area of the region bounded by, right, this area. Okay, this shaded area we have to find out. So area is calculated by integrating the given function between the limits, right? So we have to integrate this sine square x function between 0 to pi. This we have done earlier in the earlier examples, where we converted the sine square x into double angle formulas, right? In the question itself, it says that we have to express sine square x in terms of cos 2x. Otherwise, had the question been that we have to find out the area, just it says that find the area bounded by the region, bounded by the curve between the region 0 to pi. Then also we need to convert this to double angle formulas. So writing sine square x as, third part we are doing, by writing sine square x as 1 minus cos 2x over 2, we have to integrate this. That means we have to integrate this, write this as dx, and between the limits 0 to pi. Okay, this is equal to 1 by 2 integral minus half integral of cos 2x dx. Half integral is just x, that means it is x by 2, minus 1 by 2. Integral of cos 2x is sine 2x by 2. So this will be sine 2x by 2, that 2 into 2 will become 4. Now apply the limits between 0 to pi, right? So if we write the upper limit, this will be pi by 2, this is pi by 2, right, minus sine pi means sine 2 pi, this is 0. This is your upper limit. Okay, pi by 2 minus 0, that is upper limit, minus lower limit. When you put x equal to 0, this will be 0 by 2 is 0, minus sine 0 is again 0. So value of lower limit is 0. So answer is just pi by 2. So area under the region is pi by 2. Okay. Next, prove the identity cos x plus 3 sine x square is equal to 5 minus 4 cos 2x plus 3 sine 2x. So as you can see here, it is a whole square, and the single angles will be converted to double angles, right? That means we have to use the double angle formulas, in which there are some sine square x and there is some cos square x. Okay, so just writing the opening this LHS by using the formula of a plus b whole square. So cos x plus 3 sin x whole square will be cos square x plus b square is 9 times sin square x, because 3 square you will do, and plus twice of means 6 times 2 sin x cos x. I'm just writing directly this as sin 2x. Okay, you will write this as 2a into b means 2 into cos x into 3 sin x. So 2 cos x sin x is sin 2x, and this 3 will be the coefficient of sin 2x. So this is 3 sin 2x. This is your LHS. We need to convert this into double angles, right? So this 3 sin x that we have find out this term 3 sin 2x. Here we have to use cos 2x, which involves just cos x. Okay, because this sin square x we need to convert this into minus 9 1 minus cos square x plus 3 sin 2x. You can use either, or you can convert this cos square x into sin square x and then apply the formula of cos 2x, which involves just sin square x. Okay, I'm using the first formula, which is cos 2x is equal to twice of cos square x minus 1. Okay, so I'm converting these cos square x and sin square x into just cos square x. So this is cos square x minus 9 cos square x minus 9 plus 9 times cos square x plus 3 sin 2x, right? Cos square x plus 9 times is 10 sin square x. Sorry, what I'm writing. 10 times cos square x minus 9 plus 3 times sin 2x. Okay. Now double angle formulas means converting this cos square x into 10 times 1 plus cos 2x, 1 plus cos 2x over 2 minus 9 plus 9 plus 3 it is minus 9 plus 3 sin 2x. This is 5, so 5 plus 5 times cos 2x minus 9 plus 3 sin 2x. Okay, that means 5 cos 2x minus 4 plus 3 times sin 2x. Okay, hence proved. Okay, 5 minus 4 cos 2x. Okay, here it has converted into, means writing this sin square x into cos square x. Okay, you can easily convert this. I think I have made some calculation mistake here, right, by converting this into cos square x. Okay, you can convert this sin square x, you can convert this cos square x into sin square x, you will get the other part, means 5 minus 4 cos 2x. Okay, so using this identity or otherwise, we have to find the exact value of this integral cos x plus 3 sin x whole square. Okay, that means in the first part this identity is written like this. So integral of this function can be written as 5 minus 4 cos 2x plus 3 sin 2x. Okay, that means integral of this means integral of 5 minus 4 cos 2x plus 3 sin 2x. Okay, so integrating this will give you 5x minus cos 2x integral is sin 2x by 2. So this is twice of sin 2x. This is sin 2x divided by 2 and 4 by 2 is just 2. So this is minus 2 sin 2x, and this is sin 2x integral is minus cos 2x by 2. So this will be minus 3 by 2 cos 2x. Putting the limits from 0 to pi by 4 means 45 degrees. So let me clean this. Okay, so limit is 5 pi by 4 upper limit. 5 times x is 5 pi by 4 minus twice of sine 2 pi by 4 is pi by 2 minus 3 by 2 cos pi by 2. This is your upper limit. Lower limit is 0, so lower limit value by putting this x equal to 0 will be just 0. So 5 pi by 4 minus sine pi by 2 is just 1, so this is minus 2, and cos pi by 2 is 0. So 5 pi by 4 minus 2 is your answer. Okay. Next. The diagram shows the part of the curve y equal to cos x plus 2 sin x. Find the exact volume of the solid formed when the shaded region is rotated through 360 degrees about the x-axis. This shaded region, when it is rotated about the x-axis, right, a volume will be generated. Then what will be the value of this volume? And these type of questions means volume calculation. This was in your syllabus of AS 9709 paper number 12. Okay, so we will use the same concept that if you have to find out the volume of rotation, what you need to do is you draw a vertical strip whose length is dx and whose height is y. Okay, and if you rotate this strip, you will generate a disk. Suppose this is your vertical this strip y whose width is dx. So if you rotate this, you will generate a disk, right? A circular shape region you will form, right? Whose width is dx, right? So this will be a circular disk which has the width of dx, and the radius of this disk will be this length y. Okay, so if to find out the volume of this circular disk, cylindrical disk, exactly. So what will be the volume of this? So volume is given by area of cross section into width, right? Area of cross section means when you cut this width into this disk into infinite number of disk of very negligible length, you will get a circle. Okay, so area of cross section means whatever you get the area after cutting this, like this. Okay, which will be circular. So pi r square will be the area of cross section, and here in this case value of r will be this length y, right? This concept is already told in your AS level. I am just revising this, what do you mean by volume of rotation, right? So pi r square will be the area of cross section. In this case value of r will be y, right? And if you multiply this area of cross section pi y square into width with its width, you will get the volume of this small, you can say, cylindrical disk, right? So dv means the small value of this volume dv is pi y square into dx, right? Now you move this disk, cylindrical disk, between the limits, right? There will be infinite number of such disk, and you will get the volume of this whole region when you rotate this circular disk. When you move these infinite number of disks like this, when you move this disk from 0 to pi by 2, right, like this, you can cover the area or the volume between the limits between 0 to pi by 2. Okay, so the whole volume of rotation is just the integral of this small volume of this small cylindrical disk. Okay, this is called volume of rotation, and between the limits means you apply the limit between 0 to pi by 2. So required volume is your v. Now replace this y, since y is cos x plus 2 sin x, pi you can take outside. Integral of cos x plus 2 sin x whole square, 2 sin x whole square dx. Okay, limits are between 0 to pi by 2. So this is pi. Open the integral, open this. A plus b whole square is cos square x plus sin square x, 4 sin square x, and plus 4 times sin x cos x. So I am writing this as just 2 sin 2x, right? The moment you see sin x cos x in multiplication, use the formula sin 2x, right, by adjusting the coefficient of that multiplication of sin x and cos x. okay, dx. Cos square x plus 4 times sin square x. Again, you have to convert this into double angle formulas by writing sin square x as 4 times 1 minus cos 2x upon 2 plus twice of sin 2x, okay, dx. That means pi integral of, this is 2 cos square x, right, and again writing this cos square x, okay, let me just adjust this. First converting this into cos square x or sin square x, writing this factor as 1 minus sin square x, total number of sin square x you will get as 1 plus 3 sin square x, okay, and 1 plus 3 means 1 plus 3 sin square x. Now you can write as 1 minus cos 2x divided by 2, okay. I hope you are with me, right? What mistake I did is that I haven't converted this cos square x into cos 2x, okay. In order to simplify the calculation, means not using cos square x again into converting into that into double angle formulas, and sin square x also converting into double angle formulas. I have just saved the time to convert first cos square x into sin square x by writing as 1 minus sin square x and then counting the total number of sin square x. So this is basically 1 plus 3 times sin square x, and then apply the formula for cos 2x, which is 1 minus cos 2x upon 2 is sin square x, okay. So you have 2 plus 3, 2 plus 3 is 5, I think, okay. 5 minus 3 cos 2x plus 4 times sin 2x upon 2, I am taking this 2 outside, okay, dx. So pi over 2, after integrating this you will get 5x minus cos 2x, integral is sin 2x by 2, so minus 3 over 2 sin 2x, and integral of sin 2x is minus cos 2x over 2, so minus 2 cos 2x, 0 to pi by 2. Applying the limits, you will get pi by 2 as outside 5 pi by 2 minus sin pi by 2 means sin 2 into pi by 2 is sin pi, you will get sin pi is 0, minus cos pi is minus 1, so plus 2. Applying the lower limit with minus sign, 5 times 0 is 0, sin 0 is 0, right, and minus 2 cos 0 is plus 1, so minus and this minus will become plus, okay. So you have pi by 2, 5 pi by 2 plus 4, okay. Taking this 2 inside, you will get pi times 5 pi by 4 plus 2, okay, and this is the answer as you can see, okay. So integration of trigonometric functions is over. Let us meet with some another topic. I think integration is over with this. We do not have any integration as far as general integration is concerned. We have a topic which is further integration. This we will do after doing further algebra, which involves converting any fraction into partial fractions, okay. So first partial fractions has to be understood, then only we are able to solve some integrals which require partial fraction, and then we will do integration by parts also, okay. So your first part of integration is over. Thank you very much. See you next time. Take care. Bye bye.